Welcome to this lesson on zeros and factors of polynomials. Here, with this lesson, we're going to be talking about identifying zeros of a polynomial, and then we will be applying the factor theorem to determine if certain factors are indeed divisible into polynomials. So what is the factor theorem? Well, it says if k, some number k, is a zero of f of x, then x minus k is a factor of f of x. That means if it's a zero, that means I can plug k in for x, and I will get 0 for that value when I plug it in. So to start with, here we have this polynomial, and it's already factored for us. And what we want to know is we want to state the zeros of this. So what we're going to do is we're going to get a 0 from each of these factors. And the 0 here is, well, what value of x makes this 0? Because if I can make this 0, it won't matter what either of these are. 0 times anything will be 0. So if I plug in 3 in for 0, that will make this one 0. So x equals 3 is a 0 of this polynomial. Now to the second parentheses. What can we plug in to make that 0? That's going to be negative 1/3. If I take negative 1/3 times 3, that gives me negative 1, plus 1 gives me 0. And then finally, x plus 1, the value that makes this parenthesis 0 is x equals negative 1. So this polynomial has 3 different zeros. If I plug in 3, or if I plug in negative 1/3, or if I plug in negative 1, I will get 0 as the result. Same thing here. We have 4 factors. A lot of people get mixed up when they see an x out front. That counts as a factor. So what value of x will make this 0? Well, since we're not adding, subtracting, or multiplying anything, that's just going to be x equals 0. What about here? That's going to be x equals 1/2. What about here? Well, that's going to be x equals 1, and this is going to be x equals negative 1. Now, if you're having trouble figuring out what makes this 0, what you can do is you can take whatever is in the parentheses and set it equal to 0 and say, that's what we want, so what does x have to be? Add 1 to the other side, and then divide by 2. So if you need that extra help, just set each quantity inside the parentheses equal to 0 and solve for x. Now here we want to decide if the binomial x minus 1 is a factor of this. Now this polynomial isn't factored. Now here is where factor theorem comes in. This is a factor if x equals 1 is a 0. That is what factor theorem says. Because it says if k is a 0, in this case k is 1, x minus k is a factor. So the way to test this is to plug in 1 in for x. So wherever there's an x, we replace it with a 1. So 1 cubed is 1, 1 squared is 1, and we do indeed get 0. So that means x minus 1 is a factor. If it weren't 0, then it wouldn't be a factor. So what about this? We need to decide if the binomial x plus 2 is a factor of this. Well, that's true if x equals negative 2 is a 0. Now, how do we get negative 0? Well, if you remember back to factor theorem, it says x minus k. Well, we're not subtracting, we're adding here. So we have to think, all right, instead of x plus 2, it has to be x minus something. And that's going to be x minus negative 2. So now we want to test here to see if negative 2 is a 0. So we have negative 2 to the third plus 3 times negative 2 minus 4. So this will be negative 8 minus 6 minus 4, and so we get negative 18. So since it's not 0, x plus 2 is not a factor. Now here we're given the graph of a polynomial, and we want to identify what the zeros are. Now the zeros are the x values of any point that hits the x-axis. So in this case we have 4 values, so we have 4 zeros. X equals negative 2, x equals negative 1, x equals 1, and x equals 2. Those are the 4 zeros. Those are the x values when the graph hits the x-axis. Let's do one more. Here we have 2 of them. Right here at x equals negative 3, and over here. Now this one is in between 0 and 1. Now it looks like it's about halfway. So we're going to say that this is x equals 1/2. And so these are the zeros of this function. So take some time, practice the worksheet, come back, and we will see how you did.